All right, so let's get rid of this. Okay, so have you shared the paper yet? 2022.
Yeah.
All right, I just got it. Hold on. Okay, got it. Paper 3, which one is the bigger one? That's the paper. All right. Okay, so you will notice by the way that the reason why we didn't really have paper 2 last time, paper 3 during 2021, I think also 2020 we didn't have paper 1. Yeah. Reason being, again, half of the practical is there. Not half, but most of the practical questions are there, right?
Right.
Okay, so let me just put this up. There we go. Okay. All right, I'm also gonna share the screen with you.
Is there also, can you also share a Jamboard?
Sure. Actually, yeah, there should be a Jamboard ready. Hold on. Okay, and let's do a Jamboard here. Okay. Okay, so while I'm setting this up real quickly, okay, you can go through this first question now. Okay, so let's focus on the practical paper. First, you have a spherical soap bubble made of a thin film of soapy water, and inside of the bubble has an internal air pressure PI for inside, and then it's formed by in air of constant pressure PO outside. Theoretical prediction in the difference will be given by this equation, where I guess this should be gamma, not G, where gamma is a constant for the film and R is the radius of the bubble here. Okay, so we have this, okay, and then we have this graph. Okay, so okay, it's not here yet. Okay, so we have this graph. Let's take a look at the questions first. Suggest whether the data is consistent with theoretical prediction. Okay, according to the theoretical prediction, what do we have here?
Pressure initial minus pressure.
Okay, the difference in the pressures is equal to some value, right? But look at this value on the right. This is like this should be gamma, yeah? This should be this.
Yeah.
Okay. All right. Okay, I'll just copy the questions here in the Jamboard now. How do you think the answer should be here? What should So let's just go back to that section. Suggest whether the data is consistent or are consistent with the theoretical prediction. Is it consistent with the theory? Is it what do you think? Is it consistent with theory?
I guess it is, but I don't know how to say why.
Okay. Actually, no. It is a little bit, but for some reason, it's not as well. Okay. Okay. The reason being, well, it's a straight line. You can see that this is a straight line, right? Okay. However, look at where it intersects the y-axis.
At 1.
Okay, at 1, but here you can see here that it's not really here at the what's this, at the origin, because this is a false origin. We're starting at 12, right? We're starting at 10, not 12. We're starting at 10. So what do you think?
So you're saying that there's
So basically the idea here is, first, it must be linear. That's the first part. And the second one is, if possible, it should cross the origin. Okay. So again, the answer to all these, the answer to this question always would be whether your graph, well, in this case, our graph is linear. Our theory is linear, right? Okay.
Yeah.
How do we know it's linear? Because our x-axis is 1 over r. X is equal to 1 over r, right? And then y is equal to this whole thing, right? So I can just rewrite this as equal to y equals 4 gamma x, right? And 4 gamma is some constant.
Are you writing?
Okay,
Are you writing somewhere?
yeah, I'm writing on the Jamboard. Oh, hold on. Let me share with you the link. Okay. So while I'm waiting for this, while the link is being shared, the idea here is that okay, here is, share this tab instead. Okay, there. Okay, the idea here, and here's the Jamboard. Okay, there we go. Okay, the idea here is, there we go. You can see you. Okay, the idea here is always you should have the theory. Okay, where's my pen? Okay, the theory must match the graph. The theory, which is the equation, okay, must match the graph. And if it does, then in this case, we have already half yes. Okay. Okay. The other half again is to extrapolate this data, or basically to extend this data until you get to like to the origin. So you can see here that if we kind of extend this kind of meets that criterion as well, right? Because from here to here is 10, so that should, yeah, that looks like it's gonna go into the origin, right? So the idea, so the correct answer here, without looking at the marking scheme, yeah, the correct answer here is yes, since the graph is a straight line, as indicated by the theory. Okay. Okay. Furthermore, I'll just add that here. Furthermore, what's this? Furthermore, the line seems to extend to the left, so that it intersects the origin. Okay, so this is how you would check whether it goes to the origin, and check whether the line matches, the graph matches the equation. Okay, there. Okay, so if we look into the marking scheme, I'll just open the marking scheme on the chat box, make it faster. Okay. So once we check the marking scheme, that's exactly what it is. Okay. I'll just copy what the marking scheme says here for comparison. Okay, so here's the marking scheme. Okay, theory suggests that it is in fact correct. That's one. And then you can say either one of those things we just said. The graph or the line of best fit is a straight line, or the graph passes through the origin. In this case, it's a straight line because our x is equal to 1 over r. Okay. If we put r, if we put r here instead of 1 over r, or r raised to minus 1, right? Then it would not be a linear graph. We would have to go into we would have to go into this reason only. But once we have a linear graph, it should be like this. Okay. All right. This is always going to be true for any problem asking you whether the data is consistent with theory. If either one of these conditions is not met, then no. The answer is no. Okay? It has to be both. All right. Okay, so let's go to number 2. Show that the value of gamma is approximately 0.03. So I think I need to copy the graph on the Jamboard. So here's the question. Let's copy the graph. Show that the value of gamma is that, and also I think I need to copy the equation, the formula. Here. So here's the formula. How do you prove that the value of gamma is approximately that? Okay. You have any idea first?
Well, we definitely have to use the graph.
Uh-huh. Okay, the idea here is always look at the graph. The reason why we want straight line graphs is because straight line graphs follow this formula. Right? And remember, our y
we have to find the gradient?
Yeah, all we need to do is find the gradient and then compare that to here. Okay, so if we compare this to this, P minus pressures minus P0, that's our y, right? Our C is equal to 0. Our X is 1 over R. I'm just going to write that at 1 over R. So that means our M is 4 gamma. So you can find your gamma from the graph by using the using the gradient or the slope. Okay. All right. So now's your turn. Find the slope of the graph, then find gamma from here.
Find the slope. So we do rise over run.
That's correct.
So we have to count. Okay. See. I need a consistent point. Do we use this point?
You can use any of those points.
Why?
Actually, it's the best way to do this is to
we need
the best way to do this is to actually take 2 points from there. That's 1. That's 2. Okay, that's good. Yeah, that looks like a good point.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, I help you. Okay, I help you.
Over 1, 2, 3, 4, 5. This is so hard.
Yeah, so I think you're there. I'm helping you out with this, yeah? Ooh, that looks really nice.
7, 8. 1, 2, 3, 4, 5, 6. I'm losing my count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Brian?
I think 20. I think it's near. Yeah.
Are you counting small squares?
Yeah.
You don't have to.
Oh, do I count 5 each?
No, you just count the actual values. The rise here is here. That's the rise. Right? And then the run is here.
Ah.
So what's the rise here? It's 2.5 minus 2. Similarly,
Ah.
what's the run?
25 minus 20.
Yeah, it is.
Okay, so it's 0.5 divided by 5.
Yeah, it is. So what's that gonna be?
Okay.
Okay, remember though that you have to write that this is the slope, right? M equals that.
Um, that's 0.1, no?
Okay, so let's just write that 0.1. And remember, this M is also equal to that.
But
What we can do
okay,
now is you
fine.
can
M
equate
is
that to
equal
4
to 0.
gamma.
So you say 0. So 0.1 equals 4 gamma. Okay, and then I solve for gamma.
Then look for gamma.
0. 0.1 divided by 4.
Right, exactly. So gamma will be 0.1 over 4, and that's gonna give you,
Ah, 0.025.
correct,
0.025.
which is approximately 0.03, right? There. Okay. So whenever you're doing these problems
Ah,
for looking for a value, it's gonna be useful to use this technique. Okay. So again, we always try to make it align, and then you can use this technique of comparing slopes to determine certain values. In this case, gamma. Okay. All right. Next one. All right. Identify the fundamental units of gamma. So that's part 2. I think we can just put it in the same slide. Okay, hold on. I'll just refresh. Okay. So the second part here is to identify the fundamental units. Or what are the units first? Okay. I'm gonna give you a clue first. What's the unit for... This is pressure, right? Okay.
pressure.
And then R here would be a distance. Right? Okay. So let's kind of put the units into the equation. So
is that in meters?
So pressure, R would be in meters. So what you can do here is over meters already.
So
Right? And then gamma here. This gamma here, we don't know the unit. So we'll just keep it as gamma. 4 doesn't have a unit, so we'll just leave it blank. Right? Because we're talking about the units. Then pressure. What do you do with pressure? Pressure is pascals, which is newtons per
PA.
Actually that would be newtons per square meter, right? Pascals would be newtons per square meter. All right, so what can we do now? We can cancel out 1 meter here with that, right? And then what are you gonna do? Because it said fundamental, you have to change your newton into kilogram, meter, whatever, right? So newtons is mass times force is mass times acceleration. So the newton would be in mass is kilogram, acceleration is meters per second squared. And then we have m here. So what happens to our m? Cancels out. So the units of gamma will be kilogram
kg
per second. There. Okay. Okay, this is actually one skill that I think needs a lot of practice right now, especially among students because of the pandemic. So you're part of this. Yeah. So this is part 2. This is part 1. Okay. All right. Let's take a look at the next question. Okay. Let's just put 3 and 4 together. Okay, 3 and 4 is here. I'll copy the graph again. There. In order to find the uncertainty in gamma, a maximum gradient line would be drawn. On the graph, sketch the maximum gradient line. And the percentage uncertainty in gamma is 15%. State gamma with its absolute uncertainty. Okay, let's take a look at part 3 first. A maximum gradient line.
Yeah. Wait.
Okay, no, you can use the
You have
shift
to
key
do
again,
the-
yeah? Use the shift key.
Yeah, it's not working. Oh,
Mm-hmm.
you have to find this.
That's correct. But you can
Okay.
actually use one of those. You can use the first one you used. Okay?
Yeah, the last one is for minimum, right?
Mm-hmm. The second one is permissible, but because of the instructions of saying maximum gradient line, which one has the bigger gradient between those two? There. So you use this graph.
Wait,
I use
the
this
line.
line. Okay. So that's 15%. This one should be easy. You already found your gamma, right? Your gamma is 0.025. You can use this value or you can use 0.03. Okay. Then 15%. So you have to write this down in terms of the absolute uncertainty. So what do we do here? Just a reminder that percentage uncertainty is equal to delta x over x in x. Okay. And then the absolute uncertainty in x is equal to just delta x. Okay. So these two would be useful here. So how do you find delta x here or delta gamma uncertainty in, since you're given the percentage uncertainty, you know its exact value, just calculate.
If you take 15% of 0.03, that's percentage uncertainty.
Yeah. 15% of 0.03 equals delta x, right? So what should that be?
That's 0.0045.
Okay, 0.0045. Okay. And therefore x gamma, let's change that to gamma. Gamma would be equal to, you still write the number, the actual value 0.03, then plus or minus this value 0.0045. Okay.
That's the answer?
Yes, it is. However, uncertainties must be rounded off to one sig fig. Okay, always round uncertainties to one sig fig. I'll just put it here. Always round off, or no, not even round off, round up uncertainties to one sig fig. Okay.
What if you can't round up? Just leave it how it is.
Sorry, say that again.
What if you can't round up?
can you round down? So the idea here is no, you cannot round down. Okay. So this hold on, let's just write this down. So this becomes 0.005, right? So the final answer would be 0.03 plus or minus 0.005. Okay. Now, why do we round up instead of rounding down? Because it's an uncertainty, right? The idea of the uncertainty is that it's kind of like the limitations of your measurement, right? So if you round down, it's like you're saying you became more precise. But if you round up, you became less precise. And thing is, with measurements, you always get less and less precise the more you do it. So it's better to round up, so to speak.
So just,
Or here's another example.
yeah.
Here's another more obvious example. Let's say you're weighing something, right? And it says there that it's 5.0 grams. But the uncertainty is like 0.12 grams, right? So you could go, so let's write that here. So for example, 5 plus or minus 0. Let's put it at 12 grams. So that means the range could be between 5.12 grams or to 4.88 grams, right? Okay, but the idea here is if I round it, so if I round up, this becomes 5 plus or minus 0.1, and if I round down, this is round up, so 2, right? And then if you round down, this becomes plus or minus 0.1. Which values actually cover this? This is not enough to cover that because this is just 5.1 to 4.9. It doesn't quite cover this small difference, right? However, this does. It covers it because it's from 5.2 to 4.8, which still covers it. Okay. All right, so I'll just remove that so you don't get too confused. But again, you always round up. Okay, next. The expected value of the expected value of gamma is 0.027. Comment on your result. Just put it here. What do you think? 0.027 is the expected value.
We got 0.025.
Okay, we got either 0.03 or 0.025, right? What is... Okay, so in other words, you kind of have to go here, okay? Is this... The idea here is this within the uncertainty calculated? If yes, the measured value is correct, is accurate. If not, otherwise, the measured value is wrong. Okay, so that's the key idea here. Is this within the uncertainty calculated? If yes, the measured value. Otherwise, the measured value is wrong. Okay. Or better yet, or else one of these values, which is either measured or theoretical, or expected or measured. Okay. So that's how you would answer this question.
So I say,
So the experimental value was 0.025, right? So is 0.025 within 15% of 0.027?
Yeah, so I say it's within the uncertainty range.
Mm-hmm.
That's it.
So
That's my
if
answer.
it's within the uncertainty, accurate.
I got it.
That's all it is. Okay. So in this case, if you want to be rigorous about it, 0.002 over 0.027, you can calculate that value. Okay. And if you do, let's just do that. 2 divided by 27. That's 7%. 7.4%. This 0.02 is 0.027 minus 0.025, right? 7.4% within within tolerance, right? We'll just say tolerance of uncertainty. So results are valid. That's how I would do this solution. The marking scheme just basically says as long as you say it's supported or not, it's okay. In this case, this is how you would show if it's supported or not. All right.
Do I
Okay.
have to show this or no?
Sorry?
Do I have to show this?
Not. Say that again. Sorry, I didn't hear the last part.
Do I need to show this?
It would be better if you did.
Okay, fine.
Better if you did.
Does the answer the mark scheme say that I have to show this?
Yeah.
It does.
You don't really have to show this, but again, the idea is it's up to you how you interpret this result. Okay. So the best way to interpret the result is with some math. Okay. Okay. You could do it the other way around as well. It really depends on how you interpret this, but as long as you have some proof, this will still gain 1 mark, right? Now, here's another example of what I mean. If I do the proof like this, instead of saying 0.02 over 0.027, I'm gonna say 25 instead. If you take that, 0.2 divided by 25 is 8%. It's still within limits, right? So same answer. So even if you use a different number, that still gets a 1 mark. Okay. Now let's just say you did the wrong math. Let's say you said 0.025 over 0.027. Okay, what's that gonna be? 25 over 27 is 93%. As long as you interpret this as too large, so results are void. Results not valid.
Yeah, and I lose a mark.
That still gains. This still is 1 mark. Okay. You get the idea now?
That's still 1 mark.
That's still 1 mark because you have proof, so to speak. The proof is wrong,
No.
but you tried to prove it. It's still okay. Of course, we know for a fact that this is actually wrong. It should be either this or this.
Fine.
Right? It should be either one of these. That's correct. Okay. I would personally prefer this one though. I would personally prefer this. Alright. That's half of section A of paper 3. The other half, that's I think 2 more questions. That's just or rather a second question. Then the rest is the option. Okay. Okay, so here, let's just share this tab first. So question 2 usually has fewer marks here. So a student studies the relationship between the centripetal force applied to an object undergoing circular motion and its period t. Okay, the object is attached by a light inextensible string through a tube to a weight W which hangs vertically. Yeah, well, you get the setup, right? Now, what's the important thing here? The student collects and measures the values of t, the period, 5 times for different weights. The weight is then doubled, data collection repeated with 3 weight and 4W, and then, okay, the results are expected to support this relationship. Okay, state why the experiment is repeated with different values of W. This goes back to graphing and data. Why do we take W, 2W, 3W, 4W?
Because we wanna find why.
Okay. We want to find a value of y. Exactly. But how do we do that? Okay. Well, there are several possible answers to this, but they all revolve around the fact that the research question is the relationship of the period t to the centripetal force, right? Okay. Okay. So what are we basically looking for? We're looking for the centripetal force somehow as a function of t. And that's exactly what we have here. This is basically your centripetal force, your W, the weight, right? And then we have the period here. What are the ways to address this? You can address this in terms of the variables. You can address this in terms of what you want to do in the graph. You can address this as well in terms of what was that? In terms of you want to get a proportionality or the relationship. Basically, you want to confirm a relationship between your variables. Okay. So you see that section A is actually quite easy, right? You answer this with those possible ways of answering it.
I didn't understand.
Okay, you don't understand. Okay. Okay, remember that in any experiment, you need a dependent and an independent variable?
Yeah.
Yeah. That is how you answer this question. I think that's the best way to go through this answer. You always remember that in any experiment, there's an independent and a dependent variable. Okay, so clue. In any experiment, there is an independent and a dependent variable. Okay, so the idea now is because of this fact that because of this fact, right? That means you're gonna have to identify. Sorry, let's go back to the question first. State why the experiment is repeated with different values of W. From the equation, you can already say here. So I'm gonna say it this way. Yeah. Let me write this down. So I'm gonna say it this way. Since the equation, I'm gonna write 3 possible answers here. Okay. since the equation states that W is inversely proportional to T. I'm gonna put that word in bracket first, the inversely in bracket first, okay? The idea here is it's proportional to T. Proportional to T. Okay. Getting several values of W. Values of W to compare to T should yield should show a relationship. That's it.